Hi, AP Calculus students. Welcome to section 7.1b, area between functions. We are just doing examples. You already have the notes you need, but we're going to be looking at what about when they ask you to find an area between two functions, but they don't give the x's, right? Or the intersection points. We're going to find those ourselves on number 23 and 25. And we're going to look at number 27. What about when the upper and the lower function change in between? What do we do with that? So let's take a look here. They're asking us, like in number 23, to sketch the region and find the area. So first of all, I'm not exactly 2x squared plus 6x. I know that that's a parabola that goes upward, and they want the area between the function and the x-axis. But notice that when we do upper function minus lower function in this section, because you are always doing an upper function minus a lower function, meaning higher y values minus lower y values, you are always going to get a positive area, like a physical positive area. We're not going to get a negative area, okay? So please understand that when we were asked to find the area between a function and the x-axis, if the area was above the x-axis, it was positive. When it was below the x-axis, it was negative, right? Indicating positive accumulation and negative accumulation. But what's going on here is whenever we are finding the area between two functions and it's an upper function minus a lower function, we are always going to get a positive area. I hope that makes sense to you, okay? So let's go ahead. So they are asking me to find the area between the function and the x-axis, but they don't give me the x's, meaning I need to find them myself. I need to know where this parabola hits the x-axis. So let's go ahead and do that. So that would be 2x squared plus 6x equals, I want to know where it equals 0. So I'm going to factor a 2x. That's x plus 3 equals 0. I can see that happens here at x equals 0 and x equals negative 3. So now what I can do is, this will get my integral started, but I also can, between x's of negative 3 and 0, so negative 3, negative 2, negative 1, 0, I can sketch the parabola. So notice when I put a negative 3 in here, of course I get a 0 out. That's what I found, right? When I put in a negative 2 into the function, I get a negative 4 out. Let's check it. Negative 2, so that's 8 minus 12. We sure do. When I put in a negative 1, I also get a negative 4 out. That means that the minimum is probably somewhere in between. Of course, when I put a 0 in, I get a 0 out. So here's the area, right? So the upper function is the x-axis and the lower function is the parabola. So when I integrate again, I am going to, because I do upper function, hey, right? That counts, right? That x-axis, it's listed as a function, it counts. Upper function minus lower function. I am going to be sure to subtract the entire function. Again, this is going to give us a positive area whenever we do upper minus lower. Kind of like absolute value, right? When you always do a higher number minus a lower, it's always going to be positive when you're talking positive numbers. So let's integrate from negative 3 to 0. Negative 2x squared minus 6x. Let's see, I'm going to add 1 to the exponent, divide by the new exponent. That's a negative 2/3 x cubed. Add 1 to the exponent, divide by the new exponent. That's a negative 3x squared. And I'm going to evaluate that from negative 3 to 0. Notice on my f of b, when I put a 0 in, I get a 0 out. When I put in a negative 3, let's take a look. That's a negative 27 divided by 3. That's a negative 9 times a negative 2. That's an 18 minus, when I put a negative 3 in here, that is 9 times a negative 3 is a negative 27. So notice on the inside here, I get a negative 9 I have the negative of it right here, and I get a positive area. Again, upper minus lower, that's always going to happen. Let's take a look at number 25. They want the area between these two functions, x squared plus 2x plus 1 and 2x plus 5. I need to know where they must intersect at some point at holding a region. I need to know what it is. Okay, so let's set these two functions equal to each other to find where they intersect. There we go. Let's see, I will subtract the 2x and the 5 from both sides. So the 2x's cancel, minus 4 equals 0. Okay, I know how to solve this. This is plus or minus 2, right? X equals negative 2 to positive 2. So let's draw these functions from negative 2. We'll do negative 2, negative 1, 0, 1, 2, and let's get those intersection points. So when I put let's do the line first. When I put a negative 2 into the function, I get a 1 out. Of course, when I put a negative 1 in, I get a 3. When I put a 0 in, I get a 5. When I put a 1 in, I get a 7. And when I put a 2 in, I get a 9. There we go. So there's my line. Let's do the parabola. Of course, when I put a negative 2 in, I better get a 1 out because it said that they intersect there, right? Let's check it. Negative 2, that'd be 4 plus 4. Yep, I do get a 1 out. How about when I put a negative 1 in? That'll be 1 minus 2, that's negative 1 plus 1 is 0. Just doing some quick math here. When I put a 0 in, I get a 1 out. When I put a 1 in, I get a 4 out. And it should be when I put a 2 in that I get a 9 out, right? Because it said that they intersect there. So 2, that would be 4 plus 4 plus 1, sure enough. Here we go. So here's my region. My upper function is the line, and my lower function is the parabola, right? So let's go ahead and integrate. We will integrate from negative 2 to 2. The upper function is 2x plus 5. Minus the lower function, I'm going to subtract each term. Kind of running out of room there, right? I'll come on down. Here we go. I'm going to clean that up a little bit before I integrate. So how about, let's see, that's a negative x squared, just doing standard form here. Negative x squared. The 2x and negative 2x cancel in a plus 4. Okay, let's actually go ahead and integrate. That's negative x cubed over 3 plus 4x. We're going to evaluate that from negative 2 to 2. So I'm getting a little low on the board, but it looks like you can see it. Here, let me push this down just a little bit more there. So let's see. When I put in a 2, right here for my f of b, that is a negative 8/3 plus 8 minus my f of a, f of a minus my f of b minus f of a. I'm on f of a, sorry. When I put in my negative 2, that's a negative 8/3. Now it's a positive 8/3 and minus 8. The next thing I always do is distribute my negative. There we go. Kind of running out of room here. You know what, that's okay. I'll wander into this area here and then I'll just erase it. So we're right here. So negative 8/3 and a negative 8/3 is a negative 16/3. And plus 8 is 16. Okay, so let's write our 16 as 48/3. Here it goes, 48/3. Notice that's still 16, right? And when I add it up then, I actually get, let's see, 8 minus 2, I'm okay. There, 32/3. Notice again, it came out positive. It has to come out positive when you do upper minus lower. Oh, it's late on a Sunday. So I'm doing silly little things, but I always do in class too, don't I? So there we go, 32/3, right? It's better. Okay, I'm going to erase. You got it, there we go. And let's look at what's going on when it says like number 27. So same question, they said sketch the region and find the area. And it's between the y equals x line, 4 minus x line, and y equals 0, right? That's the x-axis. So let's graph the y equals x line, right? Just trying to get a little, there we go, it looks like this. 4 minus x, that is a line that starts up at 4 and goes down 1, right, for each. There we go. Okay, so we have this area here, right? They said the area between the y equals x line, 4 minus x, and the x-axis. So we have this area. Now, because it is a triangle, I can find this area, right? It is a triangle. It has 1/2, the base is 4, and the height is 2, right? So we should get a 4 out. But for the purposes of learning to integrate, wow, let's integrate. So notice as you go left to right that the upper and lower function changes. From 0 to 2, the upper function is the y equals x line. Plus, then from 2 to 4, the upper function is the 4 minus x line. Right? So we had to write 2 integrals because the upper and the lower function changed. So let's see, we have x squared over 2 from 0 to 2, plus this will be 4x minus x squared over 2 from 2 to 4. All right, and let's go ahead and do that. F of b on our first term is 4 over 2 is 2 minus f of a is 0, right? F of b for our second integral is 16 minus, let's see, that is 6 minus 8 minus f of a would be 8 minus 2. Let's take a look here. I distribute my negative. There we go. Notice here I have 16 minus 8 is cancels, and I have 2 plus 2 is 4. There we go. So we did get the area of that triangle. Of course, if you were doing it, you could do it the simple way, but hey, you know, lots of times 2 functions will change upper and lower, and it's not an area that you have a geometric formula for, and now you know how to integrate it. Have a great day.